Hi, everybody. This is our first official e-learning video. Hopefully you've been able to download and print the Radicals Day 1 notes off of Schoology. If you don't have access to a printer, you can just copy down in your notebook and make sure you just write down the original problem. Make sure you label a page, Radicals Day 1 notes, all that good stuff. So on your worksheet here, we've got a little warm up at the top left. I'm going to get us started on that, and then I want you to pause the video and try to fill in the rest here. So we're going to take a look here at this warm up, and we're just going back to simplifying radicals like we did before we were out of school. So one thing that you might want to do is write out your perfect squares at the top of the page. 1, 2 squared is 4, 3 squared is 9, 16, 25, etc. You can finish writing those out up to maybe 15-ish. 15 squared is 225. And then we're going to go through and remember which of these we can simplify or can't simplify. So if I'm starting in this left column here, I've got square root of 1, I know simplifies to just 1. Square root of 2 is not a nice number. There's no perfect square, and there's no perfect squares that go into it, so we just leave that. I'm not even going to write anything. Square root of 3, same thing. Square root of 4 I know is 2. Square root of 5 does not simplify. Square root of 6 does not simplify. 7. But square root of 8 does, and this is where I want to kind of remind us. We're looking to break up square root of 8 into two numbers where the first one is a perfect square. So 8 is 4 times 2. The square root of 4 is 2, so we get 2 root 2. You probably remember doing that. Square root of 9 is 3. Square root of 10 doesn't simplify. So on your next column here, I'll give you a little hint. You're going to need to simplify square root of 12, 16, 18, and 20. And then I want you to go through the other two columns as well. So pause the video, do those simplifications there, and then when you turn the video back on, we'll go check those answers. All right, see how you did here. You should have root 12 is 2 root 3, root 16 is 4, and I'm not going to read all these off, but you can pause the video and check your answers here. Ones you might have missed, like root 27, root 28. So that was just a little warm up, and we are going to need to be able to do that with what our next task is, which is adding and subtracting radicals. Okay, so in this box here, adding and subtracting radicals, we've got simplify 3 root 5 plus 4 root 5. And what we see here is that the answer ends up being 7 root 5. And you can tell that's coming from taking the 3 and the 4 and adding them together. When you're allowed to do this is if the square roots or the radicals are the same. And so the analogy I like to make is like if you had 2x plus 3x, we could simplify that to be 5x. You add the 2 and the 3, the x stays the same. But if you had 2x plus 3y, 2x plus 3y, there's no simplifying we can do. They're not like terms. So essentially we're adding together like terms. So as we look here at example 2, we've got some problems to try here. We're looking for terms that have the same radical number. So in problem A, I have 4 root 5 plus root 5. Well, if you think about that, that's really like 1 root 5. So I have 4 root 5s, and then I'm going to add another root 5, which gives me a total of 5 root 5s. And so that's your answer there. We literally just take the 4 and the 1, and we're doing 4 plus 1 to get 5. The square root stays the same. We're just adding. 9 root 3 minus 2 root 3 here in problem B. 9 root 3's take away 2 root 3's. They are the same radical, so I am going to take away 2 of them, so I get 9 minus 2 is 7 root 3. Okay. Sometimes I like to describe it as you've got 9 root 3's running around on top of your desk. They're just scattered all over the top of your desk. 2, 3, 4, 5, 6, 7, 8, 9. And then I'm going to take away, subtract 2 of those root 3's. Bye. They're gone. How many root 3's do I have left? Now you have 1, 2, 3, 4, 5, 6, 7 root 3's left. That's what we're doing with adding and subtracting. It's just the same as combining like terms. So some of you, you're catching on pretty quickly here. You're like, oh yeah, that makes sense. Okay, so part C, 9 root 2 minus 9 root 2. Well, we're taking all those root 2's that are running around the top of your desk. We're taking away all of them. So there's 0 left. You don't even have to write the root 2. 9 minus 9 is 0. All right, we get to a problem like D. Now I've got multiple terms here. So root 13, I'm going to try to find any like terms. Oh, minus 5 root 13. That goes together there. 8 root 2 goes with 2 root 2. So when I do the root 13s, remember if there's no coefficient, it's a 1. So it's 1 root 13 minus 5 root 13 would be negative 4 root 13. And then 8 root 2 plus 2 root 2 gives me a positive 10 root 2. 10 root 2, not 10 root 10. 10 root 2. Okay. So pause it for a second and try out E, F, G, H, and I on your own. And then we'll check our answers in a second. All right, there are your answers. Notice we have 3 root 5 minus 4 root 5 is negative root 5 plus 3. You could have written 3 minus root 5. That works too. In G, they're not like terms. They're different radical numbers, rad 10, rad 5, but they don't simplify either. So we can't do anything. Okay, so we're going to go to the next page here. And at the top of this page, we've got a little example of a problem now where we have to actually simplify first. So rad 12 plus 7 rad 3 doesn't look like we could combine the like terms because they're not, but I can simplify the square root of 12. That becomes root 4 root 3, which is 2 root 3, and now they are like terms. So our goal with these problems is to, if you see an addition or subtraction problem, simplify any radical that can be simplified, and then if you find some like terms, you're going to combine them. So in example 3, problem A, we've got root 2 plus root 8. So I'm going to realize the root 2 is as simplified as it gets, but root 8 is root 4 root 2. So that is root 2 plus 2 root 2, which gives you a total of 3 root 2's. Remember, this is like a 1. So that's 3 root 2. Done with that one. Root 50 minus root 2, problem B. Root 50 I can simplify to root 25 root 2 minus root 2. That's going to give me 5 root 2. Take away root 2. Careful, I'm not just like deleting the root 2. That's not what this means. This means 5 root 2's take away 1 root 2, which leaves me with a total of 4 square root of 2. 4 root 2. In C, I have negative root 7 plus root 63. Root 7 does not simplify, so it's still negative root 7 plus, but 63 is 9 times 7. So I'm going to do root 9 root 7, which is really 3 root 7. So I have negative square root of 7 plus positive 3 square root of 7 gives me, well, this is like negative 1 plus 3, which is 2. 2 root 7. Moving down here, a couple more together. Square root of 20 plus square root of 18. Square root of 20 would be 5 and 4, so I could do root 4 root 5. 18 would be 9 and 2, so root 9 root 2. And I know some of you are pretty good at doing this part in your heads. You know, you recognize root 20, we've done it a ton. If you can correctly go to 2 root 5, do it. But make sure you're getting it right. 3 root 2. I have 2 root 5 plus 3 root 2. Those aren't like terms. When I simplified this one, they did not end up being like terms, so I'm done now. We still need to simplify it to get to that point, but now there's no more work I can do. let's look at F. We're going to skip E. I'll leave that for you guys to try. When I look at F, I notice a couple things. One, they are already like terms, and they have coefficients in front. So in this case, I might actually add the like terms already at the beginning, 7 root 20. But then square root of 20, you should be thinking, I can probably break that down. And you can. So root 20 is 4 and 5. So square root of 4 times square root of 5. So one thing to remember, this is all multiplication. So this now becomes 7 times 2 root 5. And the 7 times 2 I can multiply to get 14 root 5. All right, to finish up, I want you to try the rest of the problems, E, G, H, I, J, K, all the way at the end, on your own, and then check your answers. All right, there you go. You can check your answers. A few things to pay attention to, just making sure you're simplifying every square root. When you have a problem like I, where it's 6 root 12, 3 root 75, you have those coefficients in front. They stay in front, and they get multiplied by the perfect square number that you pull out. So 6 root 4 root 3, the root 4 is 2. You do 6 times 2, you get 12 root 3. Here you get 15 root 3, so you end up with 27 root 3. In J, I did that multiplication in my head. 6 times root 9, I know that root 9 is 3, so it's 6 times 3 is 18. All right, so you can try the homework now. If you have questions, make sure you're reaching out to a teacher, to a classmate. You've got lots of resources to help you with this. Pause, rewind, watch part of the video again, whatever you need to do. Thanks for watching.